Okay, let's talk about one of the most infamous brain teasers of all time. It's a probability puzzle that has seriously tripped up even the smartest people for decades. But you know what? In the next few minutes, we're going to crack it wide open. And I promise you are never going to forget the answer.
So, picture this. You're on a game show. There are 3 doors in front of you. Behind one, a brand new car. Behind the other 2, goats. You pick a door. Let's say you pick door number 1. Now the host, who knows exactly where the car is, opens another door, say door number 3, and it's a goat. He turns to you with a smile and asks, do you want to stick with your original choice, door number 1, or do you want to switch to door number 2? What do you do?
All right, I know what you're thinking. Your gut, your first instinct is probably screaming one thing at you. But we're about to find out why, in this very specific case, your gut is totally, completely lying to you. I mean, it seems so simple, right? The host opened a door, that one's gone. So you've got 2 doors left. One has a car, one has a goat. It's got to be a coin flip, a 50-50 shot. Makes perfect sense.
And that's exactly what our brains do. They just simplify the problem right down to the 2 doors that are left and say, yep, equal chances. This feels so right, so intuitive, but honestly, it's a classic cognitive trap.
So let's pull back the curtain and uncover the 2/3 winning secret. The real odds aren't what they seem at all, and the key is hiding in a tiny detail that almost everybody misses. See, the really interesting thing here is the host. He didn't just open a door at random. He knew where the car was, and he deliberately opened a door to show you a goat. That action isn't just for showmanship, it's a massive, game-changing clue. And that single clue leads us to one simple, powerful conclusion. The absolute best thing you can do to maximize your chances of driving home in that car is to always, and I mean always, switch your choice.
Why? Because the odds are not 50-50. If you stay with your original door, you only have a 1 in 3 chance of winning. But if you switch, you literally double your odds to 2 in 3. Let's break down exactly how that works.
So let's really break this down. The secret here isn't about those final 2 doors. No, it all goes back to the probability that was locked in with your very first pick.
Think about it. When you first pointed at one of those 3 doors, you had a 1 in 3 chance of being right and a 2 in 3 chance of being wrong. And guess what? That fundamental fact never, ever changes. Everything that happens next is built on that first probability.
Let's just look at the only 2 ways this can play out. Case 1. You pick the car right off the bat. That happens about 1/3 of the time. And case 2, you picked a goat. This is the more likely scenario. It happens 2/3 of the time. Okay, let's tackle that 1 in 3 chance where you were a genius and picked the car on your first try. In this case, the host can open either of the other 2 goat doors. If you switch, you're going to switch to a goat, and you lose. So if you picked right the first time, staying wins.
But now, let's look at the much more likely situation, the 2/3 of the time where your first pick was a goat. Now, the host has no choice. He has to open the one other door that also has a goat. He's forced to, which means the remaining door, the one he didn't open and you didn't pick, absolutely must be the car. So in this scenario, switching is a guaranteed win.
And that, right there, is the secret. The host is using his knowledge to help you out. He's taking that entire 2/3 probability that your first pick was wrong and basically funneling all of it onto that single other door. He's practically pointing you to the car 2/3 of the time.
Now, if that still feels a little weird in your brain, don't worry. Let's do a quick gut check. We're going to scale this problem way up. And this is where the logic becomes totally blindingly obvious. Forget 3 doors. Let's imagine there are now 100 doors. Still just one car, but now there are 99 goats.
You go ahead and make your pick. Let's say you choose door number 7. What are the odds you actually picked the car? It's a tiny 1% chance. That means there's a whopping 99% chance the car is behind one of those other 99 doors.
Okay, now watch this. The host, who knows where the car is, walks down that long line of doors and opens 98 of them. And behind every single one, he reveals a goat. Now only 2 doors are left closed. Your door, number 7, and one other one, let's say door 52. He asks you that same question. Do you want to stick with door 7, your original 1 in 100 shot? Or do you want to switch to door 52, the single door out of 99 that the host very deliberately chose not to open? Of course you switch. It's obvious now, isn't it? The host's action wasn't random at all. He basically took that huge 99% chance and used 98 doors to point you directly at where the car is. He just handed you the win.
So you see, this isn't just some quirky little brain teaser. It's actually a blueprint, a pattern for solving other kinds of puzzles. It gives us a brand new mental model we can use. We can actually give this pattern a name. Let's call it the informed adversary forced reveal. It's basically any situation where you make a guess from a bunch of options, and then someone who knows the right answer eliminates some of the wrong answers for you. They're forced to show you the losers, which concentrates the odds on what's left.
So let's try it out. 3 cards are face down. One of them is the ace of spades. You pick one. The dealer, who knows the cards, turns over one of the other 2, showing you it's not the ace. Should you switch? Yes, absolutely. It's the exact same logic. You double your chances of finding that ace if you switch.
And really, that's the big takeaway. Once you see this pattern, you can't unsee it. So the next time you're facing a problem and new information comes along that eliminates some bad choices, you won't just trust your gut's easy 50-50 split. Instead, you're going to ask the right question. Wait a minute, where did all the probability go?